All right. Next up, we have our own Todd Tannenbaum to talk about what's new and what's upcoming in Condor.
It's hopefully functional, hopefully not malfunctioning. All right, so I'm going to try to go pretty quick because we're running behind and I am the last talk before break. What's new and what's coming up in HTCondor? So I was gonna, unfortunately, Frank is not here. I was gonna have Frank a path leader and Marone a path leader. I had a little legend. There was, when you saw this, Frank would say, voila. And when you saw this icon, Marone would say, Todd, I want to know the bad news. So maybe whenever you guys see the voila symbol, you could channel Frank and just everybody could say voila. And then Marone could say, what's the bad news? So since HTC24, we have had 39 releases in the past year with 136 features listed in the version history. Yeah, I want to make it to break. So I am not going to go over 136 features. You can read about them in the lovely more than 500-page manual. If you go to this link, you can see the release highlights, and there's also a button on that page that says, I want all the gory details, in which case you go into the manual and you get all the blow-by-blow details of what's changed. Also, when you're upgrading, I believe Tim talked about this, but make sure in the manual there's a gotchas section that talks about when you're upgrading, if you're the system administrator, these are things that maybe aren't going to be 100% compatible or that you might want to pay attention to. So users can have their jobs run inside of a Docker container. They can just place this line in their job submit file. Container image equals Docker : / and this will go off to the public Docker hub. And Amber did a great job of explaining all this. And that's right. What is the bad news? There is bad news in that Docker now has rate limits. So if you're an unauthenticated user, so your Condor job is just running and it makes, it doesn't authenticate to the Docker hub and just connects up, there is a max of 100 image pulls per 6-hour window per either IPv4 address. That could be rough if you have a 200 core server with a lot of slots, right? That you're gonna, Docker is gonna come to a halt quick. And if it's could be even worse if you're on IPv6 because your entire subnet is only allowed 100 pulls in a 6-hour window. Now, if you authenticate to Docker Hub, you get much higher limits. And if you have a Docker subscription like yours truly, you have unlimited pulls from Docker Hub, which I'm sure if Andy Pavlo had made it here, he'd find some horrific way to abuse that to his own benefit. But I'll think of a way too. So we added in HTCondor the ability to authenticate to Docker. So the idea is first on the access point, you would do your Docker login and do the whole song and dance two-factor authenticate. When you place your job, you tell the job Docker send credentials equals true. You get matched to a root execution point, and voila, everything's great. Now the question is, how does this work, right? Hopefully we don't like send the password out to the execution point or anything. And of course it works courtesy of tokens. So unlike almost all situations where everybody in this community goes to trustworthy Jim Basney's use token Emporium, in this case, the access point will go to Docker Hub, to docker.io, and get a reduced scope token to access the Docker Hub. For instance, it'll make sure the token only has read access. So even if the token is stolen when it sends it off to the execution point, nobody will be able to change any of your images. Short lifetime, all that stuff. So does this mean I could use a private Docker repository? So You can set up on Docker a private repo. Maybe you don't want this information to be shared with other people. And of course, for the answer, I am going to invoke the Livni law and say that it depends. So you are able indeed to pull private images from Docker Hub by authenticating if you're authorized to access that particular private repo. But would you really want it to contain private information? And the issue is Docker caches the image on the execution server. So where the EP lives, the Docker daemon maintains its own cache, and that cache does not have any access control. That's just how Docker made things. So the question is one of trust. Who can run Docker command line, who can run Docker command line tools at the execution point server? And do you trust those people? Now, some measure of comfort is Condor jobs themselves typically cannot run Docker command line tools, right? The Condor daemons can, because they run as Condor, and when you install Condor, you say, I allow the Condor user to run Docker commands, but the user jobs don't run as Condor, so they're not able to. So the answer is it depends. So speaking of caches, that's the Docker cache. What about, what if we're not using Docker? What if we're using, say, Aptainer, and we're sending out our images with Pelican? Well, something else we added recently is you can tell Condor to on the fly set up a Pelican cache on the execution point. So we saw earlier this week, normally with Pelican, there's data in the object store. It comes from the origin. It goes out in OSDFs. Out in OSDF, there's a cache at various locations around the country, around the world. And this allows it to be cached right at the EP, right? So maybe you have 10 jobs at the EP that all want to use the same image, or you're running a DAG and the next job is always wanting to use the same image. Instead of going back maybe over your wide area network connection to an OSDF cache and pulling it every time, you can store it right at the EP, and everything is great. So what do we say? And Marone, what do you say? You say, what is the bad news?
What's it?
Yeah, we're talking about the bad news about running a Pelican cache on the EP. What's the bad news? Well, for starters, the AP administrator needs to fragment the execution point disk space, right? So they just add one line into the execution point, which is how much space to reserve for the Pelican cache. But now you've fragmented. If I have 100 gigs free on my execution point server, I have to come up with some number to say I want to save this for the Pelican cache, and everything left can be for job scratch directories. What should that number be? I have no idea, right? What about data transferred not using Pelican, like files directly from the AP transferred with Cedar? What about files transferred with plain old HTTP from a web server? Those won't get cached here. Data is stored twice. So when maybe I have 100 gigs free on my EP, I have an 80 gig image or data file that has to go into the Pelican cache and then is copied into the job scratch directory, and suddenly my disk space is essentially reduced in half.
How does the client know that it should go to this cache?
It always goes to the cache.
To this one?
Yeah, right here.
How?
It will always go into the cache and then be copied here. So the question is, what is the cache going to throw away when a new file comes in?
No, but my understanding is that the Pelican client goes to its own GUI and says, which cache should I use?
When it's configured this way, it always goes to this cache.
Okay.
So the question is, what is it going to throw away to fit in the next file? And this gets to the last piece of bad news, is there's all kinds of knowledge at the access point. the access point might very well know that the same input file or the same image is going to be needed for a billion more jobs into the future. But this cache over here is going to do like least recently used or something. It's going to, throw away the file that hasn't been accessed most recently to make space for the new one. And that may or may not be the right decision. So coming out in HTCSS 24.9, which is that next week or next month? Which?
Well, you just saw it installed on CCC, so it's coming out at the end of this month.
The end of this month. Thank you. We have a new mechanism that allows the sharing of common files, or as Marone calls it, slot zero. But the idea is, let's say there's a file at the access point or anywhere else for that matter. It doesn't matter. It could be from OSDF. A file that comes across in job 1. Job 55.0 starts and it's running on slot 1. The execution point creates a scratch directory to hold all the input files for this job. And then along comes job 55.1. It gets also matched to this execution point. A new slot is created. And what will happen is if there's files in common between these two jobs, there'll just be a hard link in the input files. And the actual shared input files will only be transferred once. There'll only be one copy on disk. And the control here isn't some cache that's trying to divine what's happening or the future. The control is sitting with the access point. So there's currently some caveats in this first version, that's coming out. All the details will be covered by Todd Miller in his talk tomorrow at 10:45. But we're pretty excited about this first start. Speaking of giving control to the access point, we want the access point to get complete information from the execution point, but we don't want any of the execution point's opinions about what should happen, okay? Right now, the execution point gives a fair amount of information to the access point, but it also gives its unsolicited editorial opinions, like, I think this job should go on hold, okay? The idea is we want to rework things so that we give the access point the complete information and let the access point draw its own conclusions. So we've added yet another attribute in the job ad that comes from the execution point, and it's called the vacate reason string and vacate reason code. And whenever a job is interrupted on the execution point will tell the access point why it was interrupted in both a human readable string and also via a code. And Jamie went through all kinds of billions of reasons. So if you want to hear his war stories, he'll be happy to tell you them.
I wonder whether yesterday there was a comment about the 400 versus 500, whether we should adopt
the HTTP kind of
the HTTP. If I don't understand it well enough, but if I understand anything well enough,
but we could revisit some of these.
Yeah. So when you come up with these numbers, see whether there is an opportunity here.
Yep. So this is getting the information to the AP. Now the AP, from the EP to the AP. Now the AP has to make decisions on what to do about it. One mechanism that's there now is a class add expression in the AP config file that says, based on maybe the vacate reason, should the job go on hold, the evil hold, or should the job go into a cooldown state, which basically means don't put the job on hold, but make the job sit there and wait X amount of time before it gets rematched, right? So basically a retry. And there's some attributes that go in if it does go into this cooldown or retry without bouncing through the hold state, which is, when is it essentially going to be done cooling down and how many cooldowns have happened. I don't see a lot of AP users putting in lots of rules for this. We are going to be putting in a lot of default rules. So things like if the file doesn't exist in the transfer input files because the user fat fingered it, yeah, the job will go on hold. Is there a problem transferring the file and the file actually does exist in OSDF? So there's a problem at a site or a problem with a network or a problem with a specific EP. That's where we envision it would automatically do a cooldown or select a different site. So speaking of the scratch directories as well, right now on the execution point, this is what the scratch directories look like. In the EP, there's an execute directory that gets configured, it just lives somewhere. The execution point creates a directory every time a slot is activated. It creates a new scratch directory. It writes all the jobs files into this directory, and unfortunately, it also pollutes it with a bunch of Condor metadata crap, right? .machine add, .job add, .update add, .this, .that, a bunch of stuff that really isn't the user's jobs. It's a bunch of Condor stuff, how to reconnect to Docker in case I get rebooted, all this junk. And it's currently as a knob called starter nested scratch, but we plan to make it the default once we're sure it's free of bugs. We're to look like this. We're going to separate it out, the job files, into a separate subdirectory from all the HTCondor meta information so that users don't see all this junk that they don't know what it is and they wonder why it's there. Another reason for this is if we ever want to get to a place where maybe we have execution points communicating with other execution points on the same machine through the file system and whatnot, we really want our own place that isn't co-living with job files. You heard a nice talk by Cole on execution point disk reservation and enforcement.
You can go back. These two directories have the same permission?
No, they do not.
Okay.
Oh, they do not. This is, yeah, they don't.
Can you see a situation that the HTCondor part is becoming sort of part of slot 0?
Yeah, maybe. I haven't thought of that before, but
It's going to be very functional.
yeah, I'm sure it will.
Some people actually care about
Absolutely. So
Who are these people?
well, people might want to read like the machine ad and stuff, but I for all those people, I remind them that there is an environment variable set in your job that points to the machine add file. There's another one that points to the update file. You should be using those environment variables, and you will be able to read those files from here. But
changing the 400 script is difficult.
well, yeah, that would be a worry if there's thousands of scripts out there that did not use the environment variable as page 970
And non-functional.
the non-functional.
They don't explicitly define their inputs.
Yes. Cole's talk, disk reservation. I'm not going to dwell on that because break. We have another mechanism we added while we're still on the EP. The EP administrator can say, you know what, I don't want jobs to be able to do any networking. I don't want them to be able to have outgoing network access on my EP. Maybe it's running in a data center. Maybe I don't feel good about, I don't have a science DMZ. If you do this, the job will be launched only as loopback and no other network. But the Condor daemons still have networking. So file transfers in and out and chirp and all that still works. C group management. C groups is a Linux kernel feature for monitoring memory usage, making sure you don't exceed memory usage, monitoring CPU usage, making sure you don't use more CPU cores than you're supposed to. It works great with HTCondor by default if the execution point is started as root. If the execution point is launched by a glide-in without root, historically that doesn't work. However, if the system that launches the glide-in kind of grants permission to the glide-in to be able to twiddle with C groups by changing C group permissions, it actually can work. I think that's new with Enterprise Linux 8. So that's, what's that? 9. That's new with Enterprise Linux 9. And that is fantastic. So it's currently off by default, but we plan on having the execution point when running in glide-ins to try to use C groups if its parent set it up in a way that allows it to do so. HTCondor, the current version, by default, will set things up. So if your site is running HTCondor as its local scheduler, pilots that come in from OS Pool and other OSG systems, right, glide-in systems, will be able to use C groups and have all those nice benefits. So at long last, we finally have Enterprise Linux 9 support in HTCSS is all nice and happy. Voila. The bad news is it took a really long time for us to, yeah, the bad news was on a donkey that didn't want to move. It took a long time to get EL9 support in, it took too long. And several sites ran into problems along the way, especially with memory tracking. Daisy ran into problems, Fermilab ran into problems. There was a lot of problems. And even more bad news, 2 weeks ago, Enterprise Linux 10 left beta and has now been released. So who here is running EL10? All right, yeah, all right. So what went wrong? Why did EL9, especially the memory C group support, why was it so painful? And how can we do better? Well, I hearken back to Marone's slide of translational computer science. And the problem was right here. The locale, okay, is in path is CHTC and the OS pool. And the locale is where we, beta test the software heavily. The developers and everybody else is watching these locales very carefully for bugs and problems. And our locale, we were late to the party in upgrading to EL9. So this meant a lot of sites were already running EL9 before the locale was running EL9. And thus a lot of sites ran into problems with that we didn't see because we weren't using it yet. So something we're going to do is aggressively update to EL10, hopefully ahead of most people here, so we don't repeat the same problem. Last year, Greg had another one of his wonderful talks about tracing, all the wonderful ways to trace on Linux. I see Michael has the big volume. Don't you have the big volume book? I saw you had it earlier. Oh, it's back with Moat. It's making the rounds around the room. So we used the tracing and found that the SCED was blocked writing to a pipe. So it was just delayed once it got busy, wasting its time. And now we have the obligatory graph that goes up and to the right, because that's what we do at research at workshops that show graphs that go up and to the right. Once we fix this blocking on the pipe, we have the blue line, which allowed the Hertz rate of the SCED to be improved because it wasn't being blocked, writing on a pipe, which is writing the job add down to the shadow. The point being is we discovered this using the perf tools that that Greg talked about last year. And as a result, the SCED is faster. Enough admin nerdy stuff. Let's talk about tools for the user. There is upcoming a tool called the Condor DAG linter. So a little Mountain Dewy, but back in the day, compilers had a popular tool called lint. And this was to check your code before you actually compiled it. And we have a similar tool coming for DAGman. So when users want to run something from the command line, they might type a command like this. And they're like, this is what I type on the command line. And after they meet with the facilitators, they understand that to make a submit file from that, they gotta break it up into there's an executable, and then there's some arguments, and there's this thing called standard out, and a thing called standard error, and you have environment. But we have added to the submit file a new shell command. And with shell, if this is what the user types at the shell prompt, this is what their submit file looks like. So they can just cut and paste it in. Voila. I finished my slides 5 minutes ago. Right? One bad news here is, do I have the bad news? Nope. The bad news. The bad news is the user at this point still needs to have, if they're not on a shared file system, they would need to say transfer input files is, their input, their executable. Transfer output files is their output over here because it's not broken out for Condor. Maybe we can address that down the road. But this still is a nice improvement for end users. Speaking of improvements for end users, you can, if you drink enough Mountain Dew, write a submit file that will do things like run your job with 1 gig of memory, and if you get put on hold for exceeding that memory, rerun the job with 5 gigs of memory. It involves class add expressions. It involves $signs in many places. There's a recipe for it that some people cut and paste, but it's pretty nerdy. What we're thinking of doing is just making request memory and the other resources, request disk, so on and so forth, be able to have a list. So if you exceed this amount of memory, well then HTCondor will just try to get you a resource with this amount of memory and rerun the job. We talked about the CE dashboard some last year. We had a demonstration and discussed it more in the CC Star group yesterday morning. Since we built the CE dashboard, it's a very small step to make a central manager dashboard, just so you get some pool information from the central manager just by pointing your browser at it and being done. And then we also have on the roadmap a Prometheus exporter. So what this would allow is people that are in love with Grafana and want to make their own custom dashboards. This would just make it a much easier to do so. It also works well with Pelican because Pelican uses Prometheus to store its metrics. So wouldn't it be nice if Condor and Pelican use the same database technology? And so that's another reason we're doing it. Condor Who, Tim talked about it earlier, and TJ is going to talk about it more tomorrow, right? Yep. And a quick, I have about 1 minute left, quick defaults that are changing that might be surprising. The Python version 1 bindings are being dropped. Long live Python bindings version 2. For hopefully 98% of everybody, there'll be 100% compatible. We have a lot of very big Python scripts that we've struggled through and made sure they were compatible and ironed out a lot of the problems, including like Crab at CMS. But I do have a question for people that we can discuss during the break. Would you rather have import HTCondor magically bring in version 2 of the bindings and hopefully everything works the same? Or do you want to have to be explicit? And import HTCondor means version 1, and import HTCondor 2 as HTCondor is what you would put at your script to explicitly say you're moving to version 2. A few other changes. Swap space will no longer be used by default when running jobs, because that's what 95% of people want. If your execution point is swapping, running scientific jobs, you've probably already lost. Partitionable slots are enabled by default. Everybody's practically. Is anybody using static slots? Show of hands. Igor. Okay, you will have to add one line to the config saying you want to keep static slots. The jobs executable isn't renamed to Condor exec anymore. I personally am sad about that. And GPU discovery is also on by default. And last but not least, a public service announcement. January 19th, 2038 is going to be a big problem. That is when a 32-bit epoch, the Unix time will overflow. Okay, everybody talks about the number of seconds since 1970. Well, the number of seconds since January 1st, 1970 won't fit anymore on January 19th, 2038. We just tried setting the date to 2039 and all the Condor demons hung, right? So we fixed that. The class add date functions were also fixed. So you can see now you can do things like, 2025 plus 14 years. Oh, that's 2038. That's all great. This is what it did before the fix. It said it was 1902. So we had a time machine going. So you might ask, why in the world are we talking to you about something that's going to happen in 2038? And well, a lot of software that maybe some of you are involved with, financial software, or I don't know, scientific software, security software, might be thinking about things 10 or 12 years from now. Are you getting certificates, X509 certs, and maybe they have a 10 or 15-year expiration date? You're already in trouble, right? And then a lot of us in this room also write RFPs to purchase equipment with firmware like card readers, smart cards, physical security systems, all these things. I would suggest writing in your RFP now that it must be 2039 happy, or you guys will be sad in a few years. Thank you.